All right, good evening. Good evening. I hope that you all are well. Thank y'all so much for joining. Yeah, y'all know I don't really like to do the small chat as much. I'm like, whatever we came to do, let's do it. Let's handle our business, right? So this evening we're talking about they're not stuck, they're unclear. They being our young people for sure. So tell me if you've ever experienced this. If you're sitting there with a student, maybe your child, right? And they're working through a problem. And at first, looks like they've got it. Maybe we're living in third grade math life. They're multiplying 6 times 4. They get one right. They get another one right. We're rolling, right? You're feeling good. Then suddenly they pause. Okay. Or maybe we're in fifth grade math life at this point. So we're living in fraction land largely. Maybe we had to multiply. There was a word problem or story problem, sometimes people say, right? And they had to multiply 1/2 times 8. So they just learned a rule, but they thought they understood it. So now they're staring at the problem, second guessing, am I supposed to be multiplying right now? What's the rule again? They're absolutely stuck. Slash, maybe it's middle school life where they're learning more about ratios and proportions, right? And how to solve with some of those situations. So we're using some of that to help us solve equations, one-step equations, two-step equations. They start solving, they stop, then they erase. They try again, they stop, then they erase. Y'all let me know if any of those scenarios, if any of those have felt similar to you. Okay, you've seen it, you've done it, right? Depending on when you were actually helping your young person work on that. Usually what happens is we say something like, come on, right? You just did this. Do it like you did. Look at the last one. Use your example, right? Look at the last one. You know this. But what if I told you in that moment, again, it's not a motivation issue at all. And what most people miss is the young people don't say anything, right? So even if we feel like we're motivating them, we're using words and choosing phrases that we think are encouraging, it's not a motivation thing, and the young people don't say anything, but struggle is starting to happen. So sometimes we think, and hopefully if you've been here long enough, this isn't you, I'm not talking about you right now, right? But sometimes people think that when someone is struggling in math, it means that they're not trying, right? You might think that it means they're not paying attention or that they just don't get it. But that's actually not what's happening. And that's actually not where they start to get stuck, quote unquote. What's really going on is this key moment of clarity is dropping. Things aren't as clear. Am I using the right operation? Is this the strategy? Is this how I do the strategy? Let me think. So they're actually ruminating, they're thinking about it for a bit. But the reality is, when clarity drops, y'all, this might be the direction starting to feel less clear. This might be the steps to start feeling harder. And problems are going to take longer if clarity is not there. So nothing really dramatic yet, right? They still didn't say anything. This is a big deal. One of the big takeaways. They still didn't say anything out loud. So nothing dramatic, but what's happening is their confidence is following. So while we're saying you just did this, use your last example, look back at your notes, they're starting to go, mm-mm, I don't think, right? So hesitation is starting to happen, second guessing, and then avoidance. All of this is happening in the background because, again, they're not saying anything if we're not careful. So a couple things that we're going to focus on is, no, students don't just struggle, right? They lose clarity first and then confidence follows. So when we see and what we name often as struggle is usually like the secondary reaction, right? Like some people say about anger. Anger is a secondary emotion, like something else happened first. Maybe you felt embarrassed, right? You got frustrated. So something else happened first. By the time we see the struggle, those other two things have happened in the background. All right. So, y'all be honest. Have you seen this before? Please drop me a yes in the chat if this sounds familiar Or if you know that, you know what, I have misdiagnosed. I've seen students struggling. I thought maybe I needed to repeat it. I need to encourage them. Type yes in the chat if you've seen it or maybe you've participated, right? So while y'all are thinking about that, a couple things. Okay, so I said yes. Cool, cool. Because listen, it's a conversation. Y'all know we always come here to share some things, reflect, share some things, and reflect some more, right? So a couple of things instead of, right, what's 8 times 7, or we're thinking about some scenarios where our young people understand, okay, I need to multiply 8 times 7. But maybe we're shifting instead to say, okay, we want you to think about how many different ways can you show 8 times 7. Now we're going to talk about what changes though. So when we're talking about their confidence, we're talking about their clarity, then that shifts their thinking. I'm not just saying, okay, what is your final answer? Because that's where they're going to go if we're asking simply, okay, what did you get when you multiplied 8 times 7? If I'm asking how many different ways can you show, oh, we have a whole different ball game now, a whole different ball game. And on that, hold that thought, because we're gonna walk over to the polypad for a minute. Woohoo! Right? In third grade life, for multiplication, a lot of what happens is young people start to show equal groups. They love equal groups. Let me peek and make sure y'all can see this. Okay, yes. So they like to show equal groups. So sometimes this looks like this. Not this one. Wait a minute. The dot arrangements. So, right, just these different ways they can see equal groups. So, even having that conversation of what kind of situations maybe will we not want to choose this strategy for multiplication or division, right? As your numbers get bigger, for example, the example in the scenario, right? If we're looking for 8 times 7, listen, young people, maybe that's not the best use of our time to draw 8 circles and put 7 dots in it, right? So that's when we explore and make sure our young people are exposed to multiple ways. So it could be skip counting, right? We call it repeated addition or skip counting, where you can say the multiples easily. Or besides the dot arrangements, and I'm bouncing around a little bit, what happens is young people will also see, and this is in the frames, we call them the arrays, where they have these different objects. Here is just circles, obviously, right? Where they're able to use these and see these as rows and columns. So equal groups. It's a little bit not even, but I think y'all see what I'm going for, right? So just the different ways, the more we can challenge them in their thinking, what are the different ways we can solve this problem, whether it's the equal groups, whether it's the skip counting, whether it's arrays. So they're strategizing, and the strategy, their thinking is always, look at me, always more important than, okay, what is just the answer you got, right? Because now we can actually see what they're thinking and see how they're thinking. So students, again, love that equal groups. But again, we talk about how that's not always the best strategy for the different scenarios, especially the older they get. If we let them lock in there with third grade, it's okay for a moment. But then fourth grade, we're multiplying in the tens place, right? Beyond that, we're multiplying in hundreds place, thousands place. So we're making sure we're equipping our students with different strategies, the area model, lots of things. Again, we are going to do a thorough walkthrough of some of the strategies coming up soon, right? Coming up in May, we're going to do a walkthrough of the different strategies for our different operations and topics. So with that in mind, remember we talked about maybe fifth grade life, fractions. So instead of just this 1/2 times 8, right? That's what the scenario, that's what the word problem called for. Then we may ask them, where would you see this in real life and how will we represent it? So let me delete these really quickly so I can still show you how we're still making it concrete. Let me close up our number section, go to fractions. So if the problem we just said They know they're going to end up multiplying 1/2 times 8. So let's see what that looks like, especially as we could just connected multiplication to repeated addition from third grade life, right? That the same thing if we said 8 times 7 is 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. Then they know if a number is repeating, then yes, it could represent addition or multiplication. So we lean into that. The students do really well with that idea. So right here, we are showing 1/2 8 times. And a lot of times I tell young people, listen to what we say when I'm like, okay, I'm just building on the screen, right? And after I finish building, I'm telling them, okay, I'm done. Tell me about what you see. Well, I see you used 1/2. Tell me more. Do you see it more than once? Just, I see it 8 times. I'm like, 8 times. What operation is that telling us? Multiplication. So 1/2 times 8. A lot of us just learned the rule. A lot of us learned to do this. So whenever you're multiplying with a whole number, that's what some of us learn, right? You put a 1 underneath and just multiply. I'm peeking in the chat. Did any of y'all learn that way? Just make it a fraction and multiply them across, right? But imagine, and I'm peeking while I'm building, the young people having this context. If this is 1/2 times 8, and I need to give a final, what does this equal? And they're able to put the pieces together, literally. Because we usually, well, not usually, we will have done this building first. So then we just talk about, like I call it, the math happening behind the scenes, right? Ooh, it's giving me a hard time to drag today. Okay, there we go. Turn a little bit. Same thing for this one. But y'all see where we're going, that this 1/2 8 times gave us 4. So then we come back when we're talking about it. We've done this several times before we talk about the math happening behind the scenes. So if this equals this, and this is when students start learning that a fraction, our whole lives, y'all, that a fraction was just a miniature division problem, then all we see at this point is 8 divided by 2. We know that one from our multiplication facts from third grade, which is 4. But now we understand why. Let me choose a different color. But now we understand why this works, why this is okay. Slash, especially if we've already talked about a fraction being a miniature division problem, then we know that 8 divided by 1 is still 8. So we just gave the number a little bit of a makeover. We didn't change its value. So we're starting to get used to, again, the different equivalent forms of fractions. So it's a few skills we can touch on this way, right? Okay, so that was 5th grade life. So again, imagine having the conversation about where we might multiply 1/2 8 times in the real world, but then also having built up this concrete, this manipulative experience, these hands-on things to really lock in the pattern of the learning for this skill, right? And I see a lot of y'all saying, yeah, I just learned to make it a fraction and multiply it. But without context, what happens is when students see adding and subtracting, they want to do that step. But if they remember we built and it's actually the fraction repeating, then they know when to do it. Then they'll know when, without just which rule goes with which fraction operation, because otherwise it's literally a guessing game for them, literally. Okay? So that's when we also talk about and pull some of the words in, right? We're talking about not just memorizing, of course. We're talking about in the scenario, we're sharing. Maybe someone was splitting something, usually time, maybe food. So now math is meaning something. That's always the goal, to understand their thinking, but then to make them see it, right? It means something because I'm familiar with the scenario, I built it, I know where I see it in real life, all of this. Y'all, that's the shift. That's the shift from answering to actually understanding. Okay. And so this is exactly where AI becomes powerful. Let me stop sharing for a moment on that screen, but we're going to look at Again, some of the AI shift on a different screen. So I'm going to say this with this caveat, with this little disclaimer. We are going to use Chat GPT because it's pretty familiar to a lot of people. But just know that because of the work that I do, my Chat GPT is trained for math things um, much deeper than the average person's. So before we start getting into our live demo, I want y'all to understand why we're talking about leveraging and using AI in math class. Excuse me. So it's not because it gives answers faster, because this might feel a little uncomfortable, but I'm actually anti-speed when it comes to math learning. I'm like, please slow down. I give speeding tickets. Listen, because somewhere along the way, we started equating fast with smart, quick answers with understanding. And that's actually not true. You can be fast and wrong, right? Besides just being incorrect, speed can also hide confusion. I guess they got the right answer. So, shoo, they're not going to ask me any follow ups. Speed can mask gaps. Speed can make it look like a student understands something, but they don't actually understand yet or not fully. The learning can be incomplete. So when I'm talking about using AI, I'm not talking about administrative things where yes, we have a better lesson plan, maybe we remixed some questions, right? I'm talking about using AI to make thinking clearer. Because clarity at the end of the day is clarity that will build the confidence that we want our young people to have, not speed. If they understand exactly what they know and what they don't know, then they're confident on the part to focus on to grow that. They're confident in, oh, I do know this. I do understand uh, three-fourths, right? Three pieces of the four I need to get this correctly. Y'all let me know if that makes sense. I like that you care about relevancy and real life application. Definitely. So, a lot of, I'm thankful that I learned early on in my career to really kind of start lessons like that, because I would hear online and then just, as an adult at that point, people are like, we never learned how to do, what did we learn such and such for? We don't use that. And I'd be like, we do use it. But so just the framing of what do we use regularly, right, in everyday life, and just people, just whether or not we named it. So that was always one of my goals, for me to maybe name a couple of examples, but then young people being able to run with it and give more examples to see the math in there every day. That was always one of the goals, for sure. So one of the ways to get there, right? We're talking about clarity. One of the ways to get there is through better questions, not faster answers. So we're talking about better questions, y'all. Be honest before we dive into the details about the questioning. Were you taught? And I'm going to say, were you taught? Did you learn also whether or not it was said directly, whether or not it was explicit? Were you taught, or did you learn that speed meant that you were good at math? Were you taught, or did you learn, was your takeaway that speed meant that you were good at math? So one thing I'll say is, just in as much as we focus on, someone said yes, as much as we focus on, I'm going to go back to third grade life for a minute with the multiplication facts, multiplication, division. Um, many of us lived through the drills phase of math class, right? All right, you have however many questions, you have 5 minutes on your mark, get set, go. Which that was pure memorization and slash whether someone knew when to apply it, or I don't know this math fact by heart, but do I understand enough about multiplication to figure it out? Right? Do I know I can use repeated addition? Do I know I can use equal groups? So that is more where math life is with young people now with their multiplication. Yes, we want them to um, know their multiplication facts and be exposed to it and just know different ways to get there for when they don't know. Or if they're like, right, this clarity and confidence. If they're a little unsure, they have some strategies to check it out. Okay. So that is a lot of the shift. So largely, there may be some, still, like drill on your mark, get set, go, but that's not the absolute extent of, okay, your multiplication, not at all these days. So they're definitely doing like some of the strategies we saw in the polypad that's happening in class, in word problems, in different assessments and things. Yeah, so those fast fact drills, that is not the end all be all. There still may be some fluency drills as some checkpoints, but again, the landscape of how multiplication and division look and sound, it would especially look in math class these days, is much different than before. Much. So when we're talking about these questions, I'm pausing because I'm when we're talking about these questions, again, we're just focusing on how we're leveraging AI in math instruction. Because again, we're way beyond remixing questions from a study guide or for a study guide. We're way past designing things for a lesson plan. We're focusing on real time, well planned learning aspects of math, but with specific goals. And that's why I was pausing to say, how hard am I going to go? We're going to get a little bit spicy, a little bit hard today. So when I'm talking about specific goals for your questions, pause. Sometimes do we just ask questions just to ask, just to be able to check that box? / when you're designing and curating your question, do you have a specific goal in mind for that question? Yes, it's to get information, but what information? Let me tell you what I mean. Let me say a little more. Because when you're designing your question, we want to make sure that one, maybe we're asking questions to reveal where learning is incomplete, where they get most of the idea, what they understood worked for elementary, but now that we're in middle school, okay, we need to go a little bit deeper into your learning for how this works. Maybe we want to ask questions, and the goal is to get information about misconceptions, things that they just are believing or think is true, and those are very inaccurate, right? / maybe we want to ask a question to get information that reveals their thinking through their thought process on a question. So, are y'all understanding what I'm saying when I say yes, we need to make sure we have specific goals for the question? Yeah, someone said just to say you checked for understanding, but like very specific goals that will directly inform what happens next in class / what happens next in their learning for this topic. We have goals. We have different goals that we should have for the question. Very specific, not just checking for understanding. Are we trying to surface their thinking? Are we making sure that we're checking for misunderstandings / are we checking for incomplete learning? Yeah, there's several. There's several. And that's why I paused a little while ago, like, no, but we're gonna talk about it. So there's several goals, not all at once, but just knowing your topic, knowing where you are in your lesson, each question should specifically have a goal. It should not just, did y'all get it? Yes, we got it. All right, cool. No, not that. So, what we're going to do, well, first, what we're not going to do, we're not going to show everything that AI can do. It's a lot, but we're going to focus on one transformation. We're focusing on clarity. We're upgrading a basic math question to some upgraded thinking questions. So, we just talked about that basic, maybe 1/2 times 6 or 1/2 times 8, right? We're about to do a demo with that. So I'm showing you what I mean because I don't want it to just stay theoretical. Like that sounds good, that makes sense. Let me make sure I'm showing you. So, very common question. We're about to see what happens when I use AI as a thinking partner. I'm about to copy and paste. I'm going to share the screen now. So you can see. And as I said, I'm probably going to try to see if I can tell my chat to forget some of what she knows for a little bit because she is quite well versed in the math learning experience and cycle all of those things. Let me see if I can get her to forget what she pretends that she can forget. Let's see. Pretend that you don't have much background in leveraging AI in math class and answer this prompt more so as a newer AI model or platform would, that doesn't have the development that you have. Okay, we'll see. We'll see if she forgets enough. So give me 3 ways. I'm reading back. Give me 3 ways to turn the question, what is 1/2 times 8, into a deeper thinking math question that reveals student understanding. Remember, we talked about the goal. The goal being, okay, yes, we're asking a question, but for real, FR, what's the purpose? It is clear that we want to know student understanding for this question. Their thinking. That's what we want to know. So let's see what she says. Okay, so original question, she's like, okay, I'm going to answer it like an early stage. So asking for an explanation, right? Explain how you got your answer. Asking them to use a visual model where they draw a picture, connecting it to real world. If you have 8 pieces of pizza and eat half of them, how many pieces do you eat? Explain. Okay. So again, this was a basic tune up, a basic really quickly. How can I make sure that the goal is to understand student learning, to understand their thinking, their understanding rather. So again, when we're designing these questions, you all, we're making sure that we have a specific end goal in mind. Because this is the part that I want to make sure we really are not missing. It's not about designing more questions. It's not about doing that. And it really didn't give me more questions. Y'all realize that? It gave me just a couple words to put at the end that made the question more rich, that demanded more cognitively. A lot of times people like to throw around the word rigor in education, like, ooh, let's make it rigorous. But we have some, what is it called? Some red herrings, some kind of fake outs when it comes to rigor. Some people's definition of rigor has to do more so with pacing. We're moving through it quickly. Let's go, let's go. Yes, this is an accelerated class. This is a GT class. This is an AP honors course, all of these things. But the reality is, rigor is determined by the cognitive demand. What does the student need to answer this question? How much mental capacity are they going to need to make sure they solve this problem well? Right? Are they using any background knowledge to answer this problem well? Are they just everything they need? Is it right in the question? Do they have to connect concepts? Are they drawing from real world concepts plus maybe another content area, another subject? They're making connections there. So again, the longest question in the room is not necessarily the most rigorous. Some questions are just long. Sometimes we're just moving through questions quickly. But the reality is, if we're demanding and making very clear and high cognitive demands, all the things they have to pull from and need to answer the question, then that's a rigorous question. That's a rigorous question. Okay. All right, yeah, y'all can tell I'm excited. I'm going quickly, huh? But while we're talking about this, when you're even designing your prompt, just a couple other things to think about. If we said we wanted options to show student thinking, that's where we could decide, using a real world connection. Do you want modeling, right? We just talked about making it visual, or how deeply do we want them to explain? So seriously, I cannot emphasize enough how we need to have a goal, a specific goal for the questions that we ask. So this is one of those areas. I've talked a long time ago about AI, some people viewing it as a hammer or it's just giving questions, it's just remixing problems because that's all you asked it to do. A hammer can only hit nails. But if we understand the depth of the purposes of AI, right, especially when it comes to math learning, then there's so much we can do. If we think about it as a Swiss Army knife, it's multifaceted and it's moving and shaking because that's what we required of it. That's what we required of it. And that is how AI becomes our thinking partner. So the difference between asking a question slash designing for understanding in math class. That's two very different things. So when we combine this with our intentional questioning, you all, we're not guessing anymore. We're not guessing what the students understand. The students don't have questions about what they need to do, right? It's clear. Show me your visual. Explain what you did. So again, when we're clear, the young people can be clear. Nobody's guessing. What am I? When do I use this strategy? Slash, they didn't get this part. They didn't answer this question correctly. I'm not sure what they know. What were they doing? Right? Sometimes teachers give back quizzes, exams. They're like, what were they thinking? What were they doing? This is how we can ask questions along the way beforehand, so we know we aren't surprised for what they were thinking. Literally. Okay. So, y'all, have you ever felt stuck though? On that note, have you ever felt stuck trying to figure out what students know? If you were like, what, why did they do that? What were they thinking? Type me in the chat. If you've ever had that moment of, I'm at a loss. I do not know. I have no idea what they were thinking. And you were a bit stuck on what to do next because of what your student or your child showed you. Type me in the chat. If that's you, y'all know I'm always thinking about, our conversations in this space and all of our other platforms, direct work with students, conversations with parents and other educators. Y'all, I love it because it helps us design resources that are really meaningful in not just education space like the classroom, campus, district, but math learning life, because that's the goal. Math is everywhere, so we're making sure that we have some resources that can be used in all the different spaces. So I did put something together to help with exactly this. The question upgrade pack, it gives you real examples. It gives you upgraded questions because again, and I've talked about this, some of the questions some of us are asking are a bit dry, and that's why we're getting dry responses. Um, yeah, I'll say that. So it includes upgraded questions and again how to actually use the question upgrade pack, how to use it. So you're not guessing what to ask next when you see maybe there's a pause, maybe there's a hesitation, a second guessing, and I need to know what they're thinking. I need to resurface some misconceptions, right? All of that is clear. I'm going to go ahead and drop the link for that. And it's going to also be pinned to the live when this is over. Okay, but you can get your free question upgrade pack that I designed for you all for this time, especially while a lot of people are in review mode, things like that. Just making sure you're supporting whatever home space, class space. So start there, y'all. Before you try to fix everything else, start there because a lot of times our questioning, or that's the big deal. That's the big deal, the difference maker. Because at the end of the day, I want you all to really be clear and see that holistic fluency supports parents, educators, and the community at large in building math confidence, math clarity, because we need to be clear all the time, and then math identity. Do you understand and see yourself in math? Right? Is your evaluation of yourself and your connection to math, is it accurate? Because a lot of times there is an identity, there is a confidence level, but it may not be accurate. So we support those three realms, those three spheres, right? Parents, educators, and the community at large, and making sure those are accurate and solid. The math confidence, the math identity, and the clarity. So students don't just perform, they persist, you all. That's the goal. So if this shifted your thinking, even a little bit, un poquito, drop a flame in the chat. Let us know, like, yeah, this was a shift. This was enlightening. So thank you all so much for joining the conversation. It's always really good. I appreciate the reflection and dialogue that we have here. And I will see you next week. Bye.